Hello and welcome to Data Analysis with Python 0 to Pandas. This is a free live certification course being offered in collaboration by Jovian.ml and FreeCodeCamp. This is a 6-week course and we started on the 15th of August, so that was last Saturday. And we have lectures every Saturday from 9 p.m. to 11 p.m. IST in English and also in Hindi from 11 to 1 p.m. IST on Saturdays. You can register to get certified for this course at 0topandas.com. My name is Akash. I am the CEO of Jovian.ml and I will be your instructor for this course. And Jovian.ml is a sharing and collaboration platform for data science. We have been using Jovian to share all the materials for the course with you so far, and we'll continue to use it for the rest of the course. FreeCodeCamp is where we're streaming the videos right now, the lecture, and you should check out freecodecamp.org where you can learn to code for free and build great projects with a worldwide community. So for those of you who are just joining us, I'll give you a quick overview of the course. 0topandas.com is the course website where you can find all the details. This is a coding first introduction to data analysis with Python. So we started last week and we looked at some basics of Python. So even if you're new to programming, you might find it helpful. And we have video lectures every week on Saturdays with live coding on cloud-based Jupyter notebooks. And then we also have assignments for you to practice the concepts, and you can also earn a certificate by completing all the assignments and a course project. So this is what the certificate of accomplishment looks like. This certificate will be hosted and given to you by Jovian.ml and will be hosted on your Jovian profile. So this is a verified link that you will be able to share on your resume or on your LinkedIn. And the certificate will be signed by me and by Bo Kans, who's a teacher at FreeCodeCamp. So for those of you who are joining us the second time, so I have a few announcements to make. So the course has been extended from 5 weeks to 6 weeks because we had a brief interruption the last time, so the stream ended a little early. If you're just joining us, now is a great time. You can go back and watch the first lecture, and then you can stay with us for this lecture and continue working with us. The first lecture has been viewed over 100,000 times across different languages. So thanks a lot for watching it and sharing it with your friends, and let's keep that going. We hope to reach as many people as we can with this course. And the first assignment for the course is due on the 29th of August. So we will be talking about the assignment later today. So even if you've not started with it, even if you do not know about it, you are just coming to the course right now, you can get started. And finally, we are still accepting enrollments, so please invite your friends to join the course. And with that, today we are going to continue working on the basics of Python. So last time we looked at certain basics like variables and data types and a little bit of arithmetic operations and logical operations. Today we will take the next steps. We will talk about conditions, loops, and functions, which are all very important parts of the Python programming language and programming in general. So with that, let's get started. So to begin, where you should go is the course page 0topandas.com. Here you will be able to find all the details about the course. So there are, as I mentioned, the duration is now 6 weeks. So you can find the details of all the 6 lessons or the 6 lectures that we are going to have. So far, you will only be able to access lessons 1, assignment 1 and lesson 2. So today we are doing lesson 2. So let's open it up. And also wanted to briefly mention, you will see an enroll button here. So if you want to get certified, you will have to enroll into the course to be able to submit assignments. And you can share the course with your friends, either publicly or privately. So please do invite your friends to do the course, get to do a project and get certified. So let's open up lesson 2, and you will be able to watch the video here now or later. And you can also watch the video in Hindi if you want to. You have a link here. And in this lecture, we are going to pick up where we left off in lesson 1. So I'm just going to open the first notebook and let us start from there. So you can click on variables and data types, the notebook link. So here we have this. We were looking at a quick tour of variables and data types in Python. By the way, during the lecture, if you have questions at any point, you can, if you see here, there is a link to a discussion forum. So you can simply click on the discussion forum link and you will be able to log in here with the same user ID you used to enroll. So please use this thread for asking questions. So lecture 2 Python functions and working with files. Any questions that you have, please ask them here. To ask a question, all you need to do is make sure you are logged in, and then you will see a reply button here. So you click on the blue reply button and start typing. And then you will see your message posted. If you see a question that you already like, then please just like the question and we will try to answer the most popular questions today. And the ones that we cannot answer in the lecture, we will answer later on the forum. And we also have office hours that I'll talk about where we will answer these questions. So with that, let's start moving ahead. So I am going to run this Jupyter notebook, but if you're watching live, please do not run it right now. Please run it later. The way to run this is to go click on the run button and click run on binder. This will take this notebook and run it on an online platform which allows you to run Jupyter notebooks and Python code for free. Again, do not run it right now. Please do this after the lecture. So right now you can simply watch. And this might take a minute or two, or sometimes it might take up to 5 minutes. But in a lot of cases, it will get started pretty quickly. So while that starts, I just want to do a quick recap of what we talked about the last time. So we started with variables. We talked about how you can create variables in Python, and the way to create them is using an assignment statement. So you type the name of a variable and then you put the equal to symbol, and then you simply type the value that you want to put into the variable. So variables are like containers for data, and once you store data within a variable, then you can access its value by simply invoking the name of the variable. We looked at certain rules for what a valid variable name looks like. So things like a variable is today Saturday, my favorite car. All of these are valid variable names. And then we looked at some invalid variable names. So variables cannot have spaces within them. Variable names cannot have special characters, and variable names cannot have hyphens, or even variable names cannot start with numbers. They can have numbers in between, but they cannot start with numbers. And after the discussion of variables, we talked about data types in Python. So the data that is stored within any variable is of one of many types. And we were looking at certain commonly used data types in Python. So we had looked at integers, which are nothing but numbers which do not have a decimal point. And then we looked at floating point numbers. So floating point numbers are those which have a decimal point. Then we look at booleans, which have the value true and false. Then we looked at the none data type, which simply has the value none. And we started looking at strings, and that is where we ended the previous lecture, and that is where we will pick up today. So looks like this is taking a while. So what I will do is, I have this running already. I clicked run just before starting this live stream. So I'm going to open this up. Oops. Okay. Looks like I might have to run it again. All right, let's give that a minute and let's come back to strings and review what we had covered in the previous lecture. And by the way, everything that I just mentioned, you can always go back and watch in the previous lecture, or simply follow along with the notebook. All right, so in the interest of time, since binder seems to be taking a while, what I will do is, I have this running on my computer as well. Okay, we have it here. All right, so the first thing you need to do is click kernel and restart and clear output. So this will simply clear all the output cells from this Jupyter notebook. And again, we've talked about Jupyter notebooks in the previous lecture in a lot of detail. Then the next thing I'm just going to do is I'm just going to hide the toolbar for you so that you can see more of the screen. Okay, so let's get into it. So we were talking about strings. So strings are used to represent text or a string of characters in Python. And then we looked at different ways to create strings. So this was a simple way where you simply use double quotes and then put whatever text you want to put into the string into those double quotes. And then we also saw that strings can be created using double quotes or using single quotes. So there is no difference. The places where you might want to use double quotes is when the string inside internally may itself have a single quote, and the places where you want to use a single quote is where the string may have a double quote. Otherwise they are interchangeable. We also looked at ways to create multi-line strings. So for instance, this is a multi-line string which spans many lines, and the way to create a multi-line string is to use 3 quotation marks. Right, and then you can then print back these multi-line strings using the print function, and you can see it is it prints out the same string as expected. If you use a single quotation mark here, you might get an error. So I suggest trying it out as with Jupyter, or every time you have a question, you should simply try it out and see what happens. Then we looked at the len function, which can be used to calculate the length of a string, so the number of characters in a string. And then we also looked at how to access specific characters within a string. So if you have today is the string Saturday, then if you want to access the first character of the string, so you do today 0. And similarly, we have today 3 and today 7. And you can check if a particular string is part of a bigger string. So for instance, if the string today is Saturday, then you can do day in today. And by checking day in today, you get back true or false. So for instance, if you check days in today, you get back false, but day in today returns true. Sun in today will return false. So that's how you check whether a string contains a piece of text that you want to check or not. Then you have, you can join strings or concatenate them using the plus operator. So unlike adding numbers, using the plus operator with strings simply puts them together. So for instance, here we have a full name, Derek O'Brien, and then we have a greeting. So if you do greeting plus full name, these 2 strings will get joined. And this is a very common thing we do. It's like we spend a lot of time working with strings in Python and combining strings to format different messages. Now, one common thing that you might miss is that if you forget to give a space, because Derek O'Brien ends with an N and then here it starts with a hello. So if you just use a plus symbol, then here you might run into issues where this becomes a single long word called hello Derek, and you probably don't want that. So that's why what you want to do is you want to have a string here in between, which is an empty string, or just which is a space. It's very different from the empty string actually, which is a space, and then you have the full name. And then if you want to add something at the end, you might do that as well. So you can add many strings together. Okay. So that's pretty much what we looked at the last time. So now strings in Python have many built-in methods, and these methods can be used to manipulate these strings. So we've looked at certain functions. So there's something called the print function, and then we looked at functions associated with data types. So similar to functions, there are these methods which are also functions, but they are associated with specific data types, and they are accessed using the dot notation. So any methods that are associated with strings can be accessed by taking the name of the string, taking the variable name of the string, or taking an actual string and then using a dot and then calling the method. So in some sense, what this does is that the function now lower is no longer a function that is globally defined. So only certain data types have the lower method, and in fact only strings have the lower method. So on the strings, you can call the lower method by calling today.lower, and this lower method automatically gets access to the string that you are calling it on. So it has access to the value of today, and it performs a certain operation, and in a lot of cases it can return a certain result. So for instance, when we do today.lower, what happens is if you type today, so today was Saturday with a capital S, that becomes Saturday with a lowercase s. And by the way, this is just a reminder from the last time to run a cell the way I'm executing each of these cells. So these are code cells, the way I execute them. One way is to go cell, run cells. Another way is to click the run or the play button from the toolbar. But the easiest way is to just do shift plus enter, and that is going to run the cell. And if you want to add a cell below or above a certain cell, so to add a cell below, just click escape plus B, and that is going to insert a cell below the cell that you're currently looking at. And escape plus A is going to add a cell above. Okay. So we looked at the lowercase function, which is a lowercase method, which takes the string and converts it into lowercase. Then we have an uppercase method. So we do Saturday.upper, and that takes a string and converts it into uppercase. And then there is another function called capitalize. So I will let you figure out what this does. But basically this takes Monday and returns this. Okay. Now, these are pretty simple methods, but there are also some really powerful methods that we use all the time. So one is the replace method. So in the replace method, what we're going to say is we're going to take Saturday, the string, and then we're going to call replace and then give it a couple of inputs. So we want to give it the input, what do we want to replace? So let's say we want to replace Saturday, and what do we want to replace it with? So let's say we want to replace it with Wednesday, and that makes Saturday Wednesday, right? So this is something that you might do from time to time within a string. But do note that any string methods, and this is unique to strings, any string methods will always return a new string. They will not modify the original string. So for instance, even though another day has the value Wednesday and today still has the value Saturday. Okay. And this is a key thing to watch out, whether methods modify the existing object or they return a new object. Okay. And we'll see with lists how that is different. Another one is a split method. So I will let you check this out. The split method is pretty useful. There is one more called the strip method. The strip method can remove spaces from the beginning and the end of a string, not from the middle. So that is also pretty useful. It can remove white space characters, it can remove new line characters, and a lot of other useful things. So these two are pretty useful when we are reading in data from a file, and we will see that over time. Then one very useful method is the format method, and the format method is used to combine the values of other data types with strings. So let's look at an example here. So here we have a few variables. We have the cost of an ice bag, and then we have a profit margin, and then we have a number of bags. So you might remember these from a sample problem that we solved in the previous lecture. But as such, they are just three variables that we have initialized, and they have different data types. And then we want to output a certain message. We want to say that if a grocery store sells ice bags at a certain rate per bag with a profit margin of a certain %, then the total profit it makes by selling a certain number of ice bags is such and such, right? And we want to do this for many different, let's say we want to do this for many different combinations of price, profit margin, and number of bags. So what you can do is you can create this string and you can leave out gaps. So wherever you want to fill in a value later on, you can simply put in these braces, or what are also called curly brackets sometimes. And you can see that we have just created a string, and this string has a bunch of braces inside it. And now what we can do is on this string, which we have called output template, on the string we can actually invoke the format method. So what I've done here is, first I have done some calculation. So I have multiplied the cost of the ice bag, which is some commodity we are selling, with the profit margin, with the number of bags, and that gives us a total profit. Now with the total profit, we want to insert all of these numbers. So these three variables and the total profit, we want to insert it into the output template. So we say output template dot format, and then after saying dot format, we give a list of variables. So these can be variables, these can actually be some expressions. So for instance, here I'm multiplying the profit margin, which is 0.2 by 100 to convert it into a percentage, and then the number of bags and the total profit. And then what happens is when you use the format method, that gives a new string back, and that new string has the variable values inserted inside it. So now you can see it says the grocery store sells a bag at $1.25 per bag with a such and such profit margin, and by selling 500 ice bags, the total profit is $125. So this is something that we will use all the time. So do get used to the format method, just play around with it. Instead of formatting, you can also use the string concatenation operator to achieve this. But you might get issues when you're trying to concatenate or you're trying to add strings with numbers or other data types. And the way to actually solve for that is to take each of these variables which you are doing concatenation with and convert them into a string using the str function. Okay, so you see here we get an error here, but here we can use the str function. But the key idea here is that strings have methods, and you can call these methods, you can give them some inputs, and often these methods return new results. So as you experiment with these notebooks, try out these string methods and then try out some other string methods as well. So that's pretty much all we are covering about strings. Just like other data types, you have the str function, which can take any data type and convert it into a string. So that's one thing. And then another minor thing is that you can actually compare strings. So here I have declared a string. So you see the single equal to here. This is an assignment operator. So I've declared a string first name with the value John. And then I can compare the first name with another string using the double equal to operator. So the comparison results false with Doe, and the comparison returns true with John. So we have the equality operator, and then we also have the not equal operator, which is in our case, well, first name not equal to Jane, which returns true. Okay, so that's it about strings. So let's move on to lists. So a list in Python is what you can probably tell. It's an ordered collection of values. And lists can hold values of different data types within them. So you may be familiar with arrays, or you may be familiar with lists in other languages like C or C++. If you're not, that's fine. But if you are, then you might know that sometimes these lists can only contain a specific type of value. But in Python, there is no such requirement. Lists can contain different types of values as well. So this is how we create a list. So I'm saying fruits equals apple, banana, and cherry. That is a list. And if you check the type of fruits, you will get back the list as the type. Now here is another list. This has a bunch of different kinds of values. It has a number, it has a string, it has the none object, it has 3.14, the value of pi, it has fruits, another list as an element or a member of the list, and it has an expression which resolves to true. So that's nice that lists can contain all of these different things. And then a list can also be empty, and to create an empty list, you just create you just open these brackets with nothing, right? So to create a list, you need to open a square bracket and close a square bracket. Now, just like strings, you can check how many elements there are in a list, how many members there are, using the len function. So the fruits had 3 members, and you can also then take that and use that in string messages using the print function or using the string formatting function, and so on. And then you have similarly, here is another list. So the other list had 6 members, and then the other list had 0. So that's how you check. That's how you check the length of a list. Then if you want to access an element that is present inside a list, and then to access an element, what you need to do is you need to use the array indexing notation or the list indexing notation, which basically means the variable name followed by a square bracket followed by an index. So in Python, elements are indexed from 0. So now you have the 0th element, the first element, and the second element. So I like to say 0th element because that makes it easier for me to type these things out. You might call apple the first element, but if you start thinking of it or just mentally calling it the 0th element, you will make fewer mistakes while accessing specific elements from lists. So here's the 0th element, and here's the first one, and here's the second, right? Now one interesting thing about lists is that you can also, you can put in any number here, And if you put in a number that is larger than the size of the list, or even equal to, because the size of the list is 3, but the only valid indices are 0, 1 and 2. So if you put in a value that is bigger, then Python will give you an index error. And you might expect that, if you want to access a list and you're accessing a value that does not exist, you get an error. But if you put in a negative value, so specifically if you put in -1, then this is what you get back. You get back cherry, which seems to be the last element of the list. So lists also support negative indexing, and when you're doing negative indexing, it starts from the end. So here this is -1, this is -2, and this is -3. And this is a very useful way when you don't know the length of the list, you still want to access the last element. So you can just put in -1 and get the element back. So that's something that you can try out. But again, if you go too far negative, you're going to get an error. Another thing that you can do is you can also access a whole range of values within a list. So for instance, here I have a list, and then this has 1, 2, 3, 4, 5, 6 elements. You can see here it has 6 elements, and one of the elements itself is another list. And now if I want to access the second element to the fifth element, I can simply put in 2:5, and that's going to give me a sub list of the list. So the result is also going to be a list. So let's just guess what the answer might look like. So we have the 0th element, we have the first element, and then we have the second element. So it starts at this. So you will get back none. You will get back, so this is the third element, 3.14, you will get back this. This is the fourth element, apple, banana, cherry, the fruits list. We should get back this as well. And then this is the fifth element. But here's the key thing, ranges in Python do not include, they end one step before the last element that is given. So when you say 2 to 5, that actually means the indices 2, 3 and 4 only, not 5. And that is why you get back a list containing the 3 elements, none, 3.14 and the fruits list. Okay. Now you can play around with ranges. There are a few exercises that you should try out. Try setting indices to a range that is higher or lower than a particular than the size of the list, like 2 to 10 or 2 to 5 or 2 to 7. Just see what happens. Try leaving out the start index or the end index and see what happens. It works, but can you figure out what it does? Try using ranges with negative indices. All right, so I have left a few blank code cells for you to try this out. So just accessing lists, there are a lot of different powerful ways to do it, and ranges is probably one of the easiest ways that you should get a hang of. Okay, so now we've looked at what lists are. We have looked at how to check the length of a list, how to get elements out of a list. But what you can also do is you can modify the list. So lists in Python can be modified, and the way to do it is, if you want to change the element at a particular index, you simply access that index and then use the assignment operator to put in the element. So what that does now is, now banana gets changed to blueberry. So that's good. Now we are modifying a list. Another way to modify a list is to add something at the end. And to add something at the end, we use the append method. So we use the append method here. Another thing that you can do is you can insert an element at a specific index. So at the first position, this is the 0th position, so this is going to be the first position. So just before this element, something is going to get inserted. So you can see here that banana got inserted before blueberry. And then you can remove a particular element from a list as well. So just try remove as well. And then there is another method called pop. So remove takes a value and removes that value from the list, and then pop takes an index and removes the value at that index. So I'll let you try those out. I'll leave those as exercises for you. Then similar to strings, you can check whether a certain element is a part of a list or not. So if we check pineapple in fruits, here's a fruits list. So if we check pineapple in fruits, we get back false. But if we check cherry in fruits, we get back true, because cherry is in fact part of the list. Now note that you have to put in the entire element exactly to match. So if you put in just like cherries, or if you just put in CHER share, that is not going to work. All right. So the element has to match exactly, and then you will get back you will get back a true result. So that's how you check if something is part of a list. And then to combine two or more lists, again, pretty straightforward. You simply take a list and then you say the fruits, and then you use a plus symbol, and then you put in another list, and then you put in one more if you want to. You can concatenate or combine any number of lists. So there you go. Now this we have the combined list now. So those are some operations that you can do with lists. And just like strings, there are also certain methods that you can use on lists. So what we will do is I will leave these list methods for you to try out as an exercise. So there are some methods that are mentioned here. So for instance, there is a copy method that is used to create a copy of a list. And then there is a remove method. And then there is a pop method. So these are things that we have seen. So you can try out more of these methods, and I've provided a link here. And try to use these methods to answer these questions. So here I have certain exercises for you. So reversing the elements of a list is one. Adding elements from one list at the end of another list. Sorting a list of strings in alphabetical order, and sorting a list of numbers in decreasing order. So just see if you can check out these references, and you can you can do these exercises. And if you cannot, then a good place to discuss or post where you are getting stuck would be the lecture forum thread. There's a lot of activity going on there. So just post your question, and for sure somebody will answer your question. Okay. Now, similar to lists, there is another data structure called tuple. And the difference between lists and tuples is that tuples are immutable, which means they cannot be modified once they have been created. So for instance, here I'm creating a tuple, and the way to create a tuple is instead of a square bracket, you simply use a round bracket, parentheses. And they support very similar operations. They support very similar ways, like you can check the length. The length is 3. You can check an element with a positive index, with a negative index. You can check if a fruit contains an element. So the dates is a part of fruits. And you can also check if, but what happens if you try to change an element? So if I try to set fruits 0 to avocado, that is going to give you an error. And you cannot append to a tuple, and you cannot remove elements from a tuple. Okay. So that's one of the key differences. So we use tuples when we want to make sure that a list of elements cannot get modified. And we use lists when we can allow modifications, when we want some flexibility. Okay. So that's about tuples. And then there is a little more that you can explore here about tuples, and you can convert tuples to lists and lists to tuples and back and forth. There is no difference here. And just like lists, tuples have some methods as well, but a fairly limited number of methods. And finally, I want to talk about dictionaries. So far we've talked about lists, which is an ordered collection of values. A dictionary is an unordered collection of values. So there is no specific order to the values stored in a dictionary. Now, if you do not have order, how do you access these values? So what dictionaries have is that apart from values that you put into the dictionary, they also have keys. So in a sense, it is a lookup table that, so this is how you create a dictionary. You open a curly bracket or a brace, it's called, and then you close a brace, and between the brace you create key value pairs. So which is you create so typically keys are strings. So you have a key here, and then that key points to, so using the colon, you mentioned that the key points to a certain value, and the value can be of any data type. So the key name points to the value John Doe, and the key sex points to the value male, and the key age points to the value 32, and the key married points to true. So this is a much nicer way of storing information, let's say about a person, rather than just putting all the values in a list, because then you would have to remember what the first element represents and what the second element represents and so on. But here we have encoded it into the dictionary itself. So I've created a dictionary here, and now if I do person 1, you can see that the dictionary is, you can see that all these keys and values are present in the dictionary. And then there's another way to create the dictionary using the dict function, which has more of like a function invocation syntax, but it does the same thing. So here you can see that just like person 1, we have created a person 2 with a different name, sex, age, and married keys. Okay. but the type of each of these is a dict. So there you go. Now, when you want to access a value from a string, from a dictionary, you do it by providing the key. So this is the thing with dictionaries, that you need to know what keys you want to access, right? So if I want to access the name of person 1, I use the same indexing notation, which is the square bracket, and then I simply put in the key. So here I will put in the key name, and when I run it, I get back John Doe. Similarly, when you do person 1 married, you get back true, and then person 2 name, you are getting back Jane Judy. And if a key isn't present in the dictionary, you get a key error. Okay. Now, if you want to avoid a key error, you can use the get method. So again, from person 2, if I try to get the address key, which does not exist, I can use a get method, and I can provide a default value that can be returned if the dictionary does not contain that key. And you can check whether a key is present in the dictionary. So this is checking keys, not values. So whether a key is present in the dictionary using the in operator. So name exists in person 1, but address does not exist in person 1. So that's how you get values out of a dictionary. Then next, you can also change the values associated with a key using the assignment operator. So here I'm using the assignment operator to set married for person 2 from false to true. And the assignment operator can also be used to just add new key value pair. So person 1 does not have an address. They have a name, sex, age, and married. But if I set person 1's address to 1 Penny Lane, now you can see that the address shows up here as well. Okay. So that's pretty much it about dictionaries. And then dictionaries have certain methods. So dictionaries provide methods to access just the keys using dictionary.keys and access just the values, or access the entire key value pairs. So that's that. And then there are many other methods that dictionaries provide, which you can try out. And we will use many of these while working on things in the future. Okay. And here are some experiments that you should try out with dictionaries. So what happens if you use the same key multiple times? How do you create a copy of a dictionary? How can you change the value associated with a key? Can you change it to be a dictionary itself? Can you have this kind of a hierarchical structure? And there are a couple more experiments. So do try these out. Again, I've left you some blank spaces to try these out. And then I've also linked to certain other places. So the Python documentation, and then certain other tutorials where you can learn more about data types in Python. So with that, the last thing that we should do, since our notebook is running on an online platform, is we should import the Jovian library and then run jovian.commit with a project name. So I'm going to set my project name to variables live, and just running jovian.commit. And now that is going to ask me for an API key, which I can get from my profile. So I just copy the API key. So this is once I'm logged into jovian.ml, I copy the API key and paste it back here. And what that does is that takes the notebook that we were just looking at, and it captures a snapshot of that notebook, and then it puts it onto your JovianML profile. So now we can close this, and then this is then now going to go away, this binder instance. But my Jupyter notebook is here for me to view whenever I need to. And I can go back and I can run it using the run button. Okay, so that's what we do. We run these notebooks on Binder, we make some changes, we bring them back. On Jovian, and then we keep making changes, and that's how we start collecting different versions of the notebook. So all the updates that you make over time get recorded. Okay, so with that, we've completed our discussion of variables and data types. Let us move on to the next topic, which is branching and loops. Once again, I'm just going to click the run button to run this on Binder. So this you can find is, well, it's just below variables and data types on the lesson page. So lesson 2 page, you can open up conditional statements and loops. So here we go. Now we have the new notebook. I'm going to do kernel restart and clear output. and I am going to hide the toolbar, and we're ready to get started. Once again, if you have any questions, please post them on the lecture thread. We will try to answer them now if possible. If not, then we will answer them after the lecture. So one of the really powerful features of programming languages is branching, and branching is the ability to make decisions and execute a different set of statements based on whether a condition is true. And what does that mean? I want to show you with an example. So here, the simplest way to introduce a branch in your code is to use the if statement, and which is written like this. So you say if, and then you put a condition after the if, and then you put in a colon. So this is to indicate that there is something below it. And now you can then put in a bunch of statements, right? And all of these statements, you have to give them a little bit of a space. So just give them 4 characters of space before the statement. So here there are 4 characters before statement, and then we have the statement itself. Then we have another statement, and all of these statements which are indented. So these 4 characters of space before a statement are called indentation. So all of these statements that are indented belong to the block, belong to an if block. And these statements get executed only when this condition is true. Okay. So let's look at an example of that. So here I have a number, and this number has the value 34. And now I'm writing an if statement followed by a block of code. So here I'm saying if a number which is 34, and this is the modulus operator which returns the remainder. So the remainder when 34 is divided by 2, so which will be 0 because 34 is even. If that remainder equals 0, so this entire condition, this entire expression returns true. So since this expression is true, then these statements get executed. So the statement we are inside an if block, and the statement print the given number, which is 34, is even. And notice that we are using string formatting here. So if I execute this, you will see that these statements get executed. Very simple, but a very, very powerful idea. And you will be doing this a lot. This is the bread and butter of programming, really, branching and looping. So let's try another example here. Now we have 33. And then with 33, we are once again checking if this condition is true. And if this condition is true, then we are going to try and print something. But you can see here nothing gets printed because this condition does not hold true. So that is basically the if statement. And what you might want though is you might want to do one thing if the condition is true, and you might want to do another thing if the condition is false. And that is where the else statement comes into picture. So what you can do is you can have a if statement, and you can have a block of code after the if statement. And then you can write else and give a colon and have another block of code. So if the condition holds true, then the first set of statements is executed. And if the condition is false, then the second set of statements is executed. Okay. So let's check it out here. So we have a number, and we say that if a number divided by 2 is, leaves a remainder of 0, then we say that it is odd. Otherwise we say that it is even. So here, since 34 is even, this gets printed. And then similarly, since 33 is odd, the second statement that the number is odd gets printed. Here is another example. So you can build these conditions in any way. So it does not just have to be arithmetic. Here is another example. I have a tuple, the 3 musketeers, and then I have a candidate. So what we do is we check whether a candidate is in the tuple. So and that makes the Python is so readable that you can just read this and understand what's going on here. So if a candidate in the 3 musketeers, then print that the candidate is a musketeer, otherwise print that the candidate is not. All right. So you can build these conditions and combine them in all sorts of complex ways. And that gives you a lot of power. Now, one other statement, which is you may or may not use this a lot, but there is an elif statement that you can use. So when you want to check not just one condition, but a series of conditions, you can use the elif statement. So I'll just show you with an example what it does very, very quickly. So what we do is here is we say that if today is Sunday, Then we print something about Sunday. Else, so else if, so elif is short for else if. So if this condition fails, then we check this condition and print something. And if that condition fails, then we check this condition. So as conditions keep failing, we keep checking the next condition. But if at any point a condition becomes true, so for instance, at today equals Wednesday, the condition becomes true, then we simply print out, then we simply execute the code inside that block, and then we ignore all of these. All right. So that is the elif statement. Keep checking conditions until the condition is true. When the condition is true, execute the statements inside that block and then ignore the rest. Okay. And there are a few details here about elif and how it is different from simply using a bunch of chained if statements. So I will leave that for you as an exercise. So here we have tried the same thing with if elif, and then we've tried the same thing with just a bunch of if statements. So I'll let you try that out. And finally, you can use if, elif and else together. So here I have the number 49. So what we do is we try to check if it is divisible by 2, and then we print it as divisible by 2. We check if it is divisible by 3, and we print that. We check if it is divisible by 5, and we print that. If none of these conditions hold true, then we go into the else block. So you can do a chain of if, elif and else statements. Okay. And then finally, what you can also do, as I've mentioned before, is within an if statement, you can take this number and you can take, you can like have a check on that number, and then you can do an and. So you can combine two conditions. So you have a number divisible by remainder with 3 equals 0 and a number remainder with 5 equals 0. And then only if both these conditions are true, you are going to go and execute this print statement that the number is divisible by 3 and 5. Okay, so that is the if else statement. Now, one other thing is that these conditions do not necessarily have to be conditions. In fact, they can be any value, and they can be any value in Python. For instance, it can be a string, it can be a dictionary, it can be none, it can be a number. And what happens is that Python automatically, whenever you put in a value that is not a Boolean, Python automatically calls the bool function on that value. And we've discussed this the last time in the last lecture, so you can look it up there. When you call the bool function, empty values like 0 or the empty string or empty dictionary or empty list get converted to false, and all other values get converted to true, right? So there are a certain set of falsy values, and there are a bunch of true values. Okay. And this is pretty useful because if you want to do a certain operation only if a particular list is not empty, then you can simply say if my list, and if my list is true, then you print something, else you print something else, right? So this is a very simple way to just check whether something is empty or not. And then again, a very minor thing, and you can try this out, is that you can have if statements inside if statements. So here is an if block. So we are checking if a number is divisible by 2 or not. And then inside the block, we have another if statement where we check whether the number is also divisible by 3 or not, right? And then what you have to do is this if statement itself has to be indented, and then the block inside it will require 2 levels of indentation because it is indented from an if statement which is already indented by 4 spaces. Okay. So check this out, try this out. First read this out line by line and try to predict what will happen as you put in a number here, which path it will follow. And as you change the number, try to see if you can get all of these print statements to show up in different cases. Okay. Now, one small piece of advice here is avoid nesting statements, if statements wherever possible. So if inside if is very, very confusing. So the maximum you should go is maybe 1 level of nesting, and try to keep your code as simple to understand as possible. Okay. So that is the if. Those are all the variations of the if statement. And then there is also something called a shorthand if expression. This is not something that we are going to cover in the lecture, but again, this is here in the notebook. So if you're going through the notebook, you can try this out. Essentially, what it offers is it offers a way to put the entire if condition statement, else statement, all of that into a single line. especially when you want to calculate a new value out of the if statement. Okay, so I will skip ahead for now. So I'm just going to save my notebook here because this is something that you should just do from time to time. Keep saving your notebooks. So here I just take my API key and paste it in here, and that uploads the notebook to Jovian. Okay. We've gotten a lot of comments about people losing their work on Binder because they left the tab open for a long time or left their computer for a while. So just keep running jovian.commit from time to time on Binder so that you do not have to deal with that problem. Okay. All right. So now we've looked at conditions. The next thing that we're going to look at is iteration. And iteration is sort of an extension of condition or an extension of branching in a sense. So what it allows you to do is it allows you to run one statement or a set of statements multiple times. So we have something called the while loop in Python, which works like this. So you say while, and then you put in a condition, and then as long as that condition is true, so let's say you're checking the value of a variable, whether it's even or not, as long as that condition is true, the statements inside the while loop keep executing over and over and over again, right? And what you might normally do is that within one of these statements, you might change a variable, which might later cause the condition to become false. Okay, and that is when the while loop will end and we will continue with the execution of the program as normal. So let's take an example. You might be familiar with the concept of factorials. So what we will do is we will try to, the factorial of the number n is simply the product of all the numbers from 1 to n. So the factorial of 10 is 1, 2, 3, 4, 5, 6, all the way up to 10 multiplied and so on. So we will write a while loop to calculate the factorial of the number, or a factorial of the number 100. Okay, and so the way we are going to do this, we are going to create a variable called result. This is what will get back the final result of the factorial, and then we are going to create a variable called I, which is, you can call it index or you can call it like a counter. So I has the value 1, and then we create a while loop. So we say while I is less than or equal to 100. So initially, since I is 1, this condition is going to be true. So then these statements are going to get executed. So first we do result equals result times I. So since I is 1 right now, then result will continue to remain 1. And then we do I equals I plus 1. So I plus 1 is 2. So now we change the value of the variable I to I plus 1, which is 2. So now I has the value 2. So now we come back here. The statement, the condition is executed again. The condition is currently still true. So then we multiply the result with 2. So the result becomes 2. And then I now becomes 3. Then we check the condition again. And then we multiply result by 3. So result becomes 1 times 2 times 3. And 1 into 2 into 3. And then we have I gets increased to 4. And now you get the idea, right? We keep repeating this over and over till this condition becomes false. That is, till I becomes 101. And when I becomes 101, at that point, this condition is false. So at that point, we break out of this loop. So it's called breaking out of the loop. And then we can go on executing the program with the statements that follow it. Okay. So let's run this. So you can see we ran this and it took hardly an instant, and it gave us the factorial of 100. And you can check whether this is actually the factorial if you want to. You can look it up online. But that's basically how this code works. And the real powerful thing here is that just with these 4-5 lines of code, we have been able to calculate the factorial of 100. But if you want to go from 100 to 1000 or even 100,000, all we have to do is change this, right? And that is what makes computers really powerful, that with a few lines of code and with their real speed of arithmetic operations, they can compute a lot of different things very, very quickly. So here we have, for instance, here we are trying to calculate the factorial of 1000, and I've added this special command called % time. So this % time is simply going to tell us how long it took to execute this cell. So yeah, I run this cell and I get back 1000 factorial, which is this huge number, pretty huge. and it took only a total of 2 milliseconds, which is like a thousandth of a second almost, pretty much, right? So that's why loops are a really powerful thing in programming, because they let you process a lot of data really quickly with a few lines of code. So now here are some exercises that you can try out with the while loop. So with the while loop, here is a pattern that I've printed out. So I've just printed out this nice pattern using just asterisk characters. So that takes a couple of while loops to print this out. So try and see if you can understand what's going on here. See if you can make sense of this code, and then use that to maybe create a couple more patterns. So here is one more pattern. This is the mirror image of that pattern. And then here is like a diamond pattern or a rhombus, putting these two together. So try and see if you can write the code for these, especially this one. It can be a little bit tricky. So if you can figure this out, then you have really gotten a good hang of loops and iteration in Python. Okay. One other thing that you might want to keep track of is that sometimes you may make a mistake while writing your code. So here I am calculating factorial, but within my while loop, I may have forgotten to increment I. Okay. So when this happens, when you forget to increment, what happens is this condition remains true forever because I is not changing. And when you run this cell, now it's just going to keep on running continuously forever, and you will not be able to execute any other code in the notebook. So this is called an infinite loop because the program is stuck in the loop forever. And the way to come out of this is to interrupt this execution or to stop this execution. And there are a couple of ways to do that. So you can go kernel interrupt, and that's going to interrupt the loop, and then you can make the change and rerun the cell. And then the other option, and by the way, here is another example. Here what I've done is I am incrementing I. So again, we are calculating factorial, and I am incrementing I, but I put in the wrong condition here. So this condition again, I can keep on going to 1 million or 2 million, but I greater than 0 will always continue to hold true. So this goes into an infinite loop as well. So the other way to stop it is if you have the toolbar open, next to the run button, you have a stop or an interrupt button. So you can simply press the interrupt button, and that is going to stop the execution. So those are the 2 ways that you can break out of these infinite loops. And don't worry, you can always go back and fix these things. So write your loops, and then if you see that it's going into an infinite loop, just interrupt and fix it and rerun it. Don't be afraid to get it right the first time. Now there is a couple more things within while loops. One is that there is a special statement called break. So what you can do with a break statement is, yes, you have this condition within a while loop, and this condition can, when the condition becomes false, you will break out of it. But sometimes you may want to, depending on a certain condition, depending on what values you are iterating upon, you may want to decide that, okay, I want to stop the execution of the loop somewhere in between. And that is when you use the if character. That is when you use the break statement. So for instance, here we have I equals 1, result equals 1. And then while I is less than equal to 100, we multiply I with the result. So this statement result star equals I is the same as result equals result star I. Okay. And then we have an if statement here, which checks that if I reaches the value 42, then we say that magic number 42 has been reached, and we are going to stop the execution, and then we are going to break out of the loop. So this break gets executed, and then we exit the loop completely, and then we execute these statements, right? So you can see here that I at the end of the while loop has the value 42, and the result is not nearly as close to the factorial of 100 that we initially had. In fact, it will be 42 factorial exactly, right? So that is a break statement. And then there is another statement, that is the continue statement. So the continue statement is slightly different from break. Break, what it does is it completely breaks out of the loop. But what the continue statement does is the continue statement. So here let's look at an example. So again, we have I equals 1, result equals 1. And then while I is less than 20, we increment I. So we go from I goes from 1 to 2. And then we check if I is even. So if I is divisible by 2, the remainder of I with 2, if it is 0, then we print that we are skipping I or whatever that number is. And then we have the continue statement. So what the continue statement does is that when this gets executed, anything else, all the remaining statements in the loop are skipped. So this print statement is skipped and this result multiplication statement is skipped. Okay. So let's try it out. Let's just run this. So you can see here we started out with I equals 1 and then we had I equals 2 in the first loop. So we skipped 2 because this if statement was true. And then we did, so there was no multiplication with 2, but then we did multiply with 3. Then we skipped 4, multiplied with 5, skipped 6, multiplied with 7, and so on. And the result that we get back ultimately is the product of all the odd numbers from 1 to 20. Okay, so that's the continue statement. So break and continue are, well, they're not very often used, but they're quite useful sometimes when you are stuck in a tricky loop where you want to somehow have something come out of the loop based on a certain condition. Okay. So those are loops, and I'm just going to run jovian.commit once again just to save my work. So those are while loops. Another important kind of loop, in fact, something that you will probably be using the most often, is the for loop. Now, just as while loop is used to iterate while a condition is true, the for loop is used to iterate or loop over a sequence. So for example, if you want to perform an operation for every element of a list or a tuple or a dictionary or every character in a string, that is when you use a for loop. And they have a very nice, simple, intuitive syntax. So what we say is for value in sequence. So for value in sequence. So we have a sequence and then we take, using the in operator, we take one by one each value from the sequence once we put it into this for statement, and then we can execute a bunch of statements repeatedly, a bunch of statements for each value from that sequence. Okay, and it'll become clear with an example. So here we have a list, and the list has Monday, Tuesday, Wednesday, Thursday, Friday. So it has these elements. These are all strings, and we say for day in days. So for day in days. So what happens is that every time for every element, Monday gets put into the variable day, and then you can print day. Then Tuesday gets put into the variable day, and then the statement gets executed. Then Wednesday gets put into the variable day, and then the statement gets executed, and so on. Okay. And you can see here, as you might expect, Monday, Tuesday, Wednesday, Thursday, Friday gets printed. And here are a couple more ways you can try this out. So we can actually loop over a string and we can get back characters from the string. So for every character in the string, we print out the character. So here Monday becomes Monday. We can loop over a tuple or a list. Well, this is more of a list than a tuple. So here we are going to loop over the list, apple, banana, guava, and then we are going to print it out saying here's a fruit. So here's a fruit, apple, banana, and guava. We can loop over a dictionary as well, which is again something that we will do a lot over the course of the next few lectures. So here we have a dictionary, and then we are going to use the name John Doe, sex male, age 32, married. And then when we loop over a dictionary, what we get back is just the keys. We do not get back actual values from the dictionary. So if you want to access the value, so here's what we do, right? So for key in person, and then we are going to print out the key. So the key is going to have the values name, sex, age, etc. And then if you want to get the actual value stored against that key, then you simply pass the key into the dictionary using the indexing operation, right? So the person key, when key is name, will give you the name, and so on. So let's run this. And so you can see here the key is name and the value is John Doe. When the key is sex, the value is male. The key is age, the value is 32. The key is married, the value is true. And that's all it is. If you do want to iterate over actual values, then you can just call the .values method on a dictionary. So person.values will now give you a list of values, and now you see we have just the values. Or if you want to get back both keys and values, then there is also something called .items, and then .items is going to give you both the key and the value. All right. So that's our for loop. With the for loop, we can iterate over a bunch of different containers. But sometimes you might want to iterate over simply a bunch of numbers, right? You might want to run something, you might want to run a loop from, let's say, numbers from 0 to 100 and then perform certain operations using those numbers. And that is where you can use the range operator, the range function. So here are a few examples. So if you just say for I in range 7, so when you say range 7 or any range n, that creates a sequence of numbers from 0 to n minus 1. So range 7 creates a sequence of numbers 0 to 6. And you can see that here, if I print it out, that's going to create the range of numbers from 0 to 6. You can also specify a start index and an end index. So what you can do is you can say range of 3 to 10. So what that does is that starts with 3 and then goes all the way up to 10, but not including 10. So that becomes 3, 4, 5, 6, 7, 8, 9. Right? So you can see 3 to 9 get printed here. And finally, you can also give a step. So here we start with 3 and we go all the way not equal to or greater than 14. So we can go all the way up to 13. But we take increments of 4. So we have 3 and then we have 7 and then we have 11 and then 11 plus 4 becomes 15, which is greater than or equal to our end index. So that is not printed, right? So this is pretty useful. A range is pretty useful when you also need access to, let's say you want to go over a list, but you also want to know within the for loop which element in the list you're accessing, right? The index of the element. So that is when a range is useful. That let's say if you're going over a list, here you have the list of days. What you can do is you can create a range with the length of the list, and then you have the index I that goes from 0 to the length of the list minus 1, right? So 0, 1, 2, 3, 4 are going to be the indexes. So you can then print that the value at a position 0 is Monday and the value at the position 1 is Tuesday, because we are formatting the string and we are putting in I, the value of the index, and then we are getting the element with that index out of the list. All right. So that is the range function. And similar to while loops, for loops also support break and continue statements. So anywhere within a for loop, if you feel like, okay, you should probably end this loop right now because maybe you found what you need of the loop. And similarly, here is the continue statement. So here you can see that beyond Wednesday, we do not process Thursday and Friday. But in the same way, if we were printing things out and we were simply doing a continue, then what happens is that when we reach Wednesday, this statement becomes true. So we print, I don't work on Wednesdays, and then we say continue. So this print statement below gets ignored. All right. So here with continue instead of break, we say today is Monday, today is Tuesday. I don't work on Wednesday, but we still process Thursday and Friday. So those are the break and continue statements. And finally, this is not very common, but sometimes you may want to just create an empty loop, nothing inside a loop. So you just say for day in weekdays and then you say pass, right? So if you say pass, nothing happens. You simply go over all the elements, but nothing really happens. Now that's it about loops that we'll cover right now. You can nest for and while loops inside each other. So I leave that as an exercise for you to try out. You can nest for loops inside while loops. You can have if conditions inside for loops, inside while loops, and so on. But again, even just as with the conditions, if you nest too many loops, it can become difficult to read and understand. So you may not want to do more than 2 levels of nesting within a loop. Okay. So that's all the discussion that we have about variables, data types, and branching and loops. And probably what we can do now is we can spend some time talking about the assignment, because the assignment only covers these topics. So now you're in a good position to work on the assignment. So you can go back to the course page, 0topandas.com, and on the course page, you can go to assignment 1. Okay. So this is assignment 1. It is a practice of Python basics. So you will be able to apply the things that we've just learned. And the deadline is the 29th of August. And the way to submit is something that I'm going to show you right now. So with the assignment, you have a starter notebook. So let me just grab the starter notebook here. So we have a starter notebook with the assignment, and then this starter notebook contains all the information that you need to know to submit the assignment. So please read it carefully and follow all the steps mentioned here. But I'll give you just a quick walkthrough and I'll show you how to make a submission. So as you go through this notebook, you will find a question mark in certain places. All right. So you'll find 3 question marks. So for instance, you can see here that there is a question. Please assign your name to a variable name. And then there are 3 question marks here. So wherever you see these 3 question marks, you need to insert your name. Okay. But you can't edit it here. You can't actually run the assignment here. So what you need to do is you need to click the run button and then run this notebook on binder. So while I wait for that to load up, yeah. So you need to run this notebook on binder, and then on binder is where you will be able to edit this notebook. Okay. So let me open up this notebook in binder. Okay. Now what you need to do is, first of all, first thing, you can do a kernel restart and clear output just to clear all the outputs. So the first thing that you should be doing absolutely is just as soon as you have run the assignment, just record a version, just save a version of this to your profile. So I'm just going to call this Python practice assignment live and just run jovian.commit here. And that is simply going to capture your notebook. Let me just grab my API key here and let me paste it here. Yeah. So that records a snapshot of your notebook. And then in this assignment, we have a bunch of problems. So we have 5 problems, and inside each of these 5 problems, we have questions. And for each of these questions, we have these triple question marks where you have to fill in some code. So for instance, I can fill in my name, Akash. I can fill in my age, let's say 78. You don't have to put in actual values here. We can't check your age. So has an Android phone, I'm going to put in true. And then remember to execute each cell that you fill in and keep answering these questions step by step by step. And what you need to do is you need to just go on and answer each of these questions in all the 5 problems. So the first problem is about variables and data types. The second problem is about working with lists. The third problem is about working with the loop. So here we will calculate this sum of numbers which satisfy a certain condition. And here again, you have to write some code here, probably like a for loop. Then the fourth problem is it is a word problem similar to the problem that we solved at the very beginning. And in some of these problems, you will see a required part, which is just marked with a question mark. And then you will also see an optional part. So we will only consider the required questions for grading. So you do not need to do the optional questions, but we highly recommend doing them because that will give you a better understanding and you will be able to practice your skills a lot better. And then finally, we have this Twitter sentiment analysis. So we have your first data analysis problem. And this is something that is very close to a real world problem that a lot of companies solve. So you have a list of tweets, and what you're going to do is you're going to figure out which of these tweets are happy tweets and which of these tweets are sad tweets. And the way you're going to do that is you're going to check whether these tweets contain specific words or not. For instance, great is a happy tweet. Sad is the word sad indicates a sad tweet. Excited indicates a happy tweet. Bad again indicates a sad tweet. And then some tweets are just neutral, which are neither happy nor sad. Okay. So this is a pretty interesting problem. And there is a lot of discussion already going on the assignment discussion thread, which I'll just show you. So you can get hints there as well. But do this assignment. It should take maybe a couple of hours, not more than that. If it takes you more time, that's all right. It's good to get as much practice as you can. And again, there are some optional questions and some required questions here. But what you should be doing every time you solve a particular problem, there is a jovian.commit statement. So just run that commit statement. What that will do is that will capture the snapshot. So always remember to keep capturing these snapshots from time to time. And then what you can do is you can simply go on your profile. So if you just go on your profile, you will find the assignment. For instance, Python practice assignment live is there on my profile. And here, this is the link that you need to then take. So the link from the browser, or you can click the share button and then click the copy link button. So get the link to this notebook, because this is what you need to do. You need to take this Jovian notebook, and then you need to go back to the assignment page and make a submission here, right? So this has to be a notebook committed to Jovian. Please don't post a binder link. Please don't post a localhost link. Please don't post a collab link, because we cannot access those notebooks. Binder gets shut down, your computer is inaccessible to us, and so is your collab. So please commit it to Jovian and then click the submit button here. And then when you make a submission, you will be able to see your submission history. And we are still grading the assignments. There are more than 12,000 participants in this course. So we will be grading them slowly. So you will get back a grade within a week or so. All right. So that's the assignment, right? So you take the notebook and then you run it using binder, and then you make some changes to it, fill out the blanks, answer the questions, commit it to Jovian, take the link, and then make a submission here. Okay. And you have all the knowledge that you need to continue with the assignment. Okay. So with that, we've completed variables, data types, loops, and we've looked at the assignment. Maybe we can take a break for about 4 minutes here. There's a lot of material we've covered already. So let's come back in about 4 minutes. In the meantime, I will also take a look at some questions and maybe answer a couple of questions. Okay, so one other thing, if you have questions about the assignment, you will see a discussion at the end. So you just click continue discussion, and you can ask questions here just as you were asking questions on the lecture thread. So, and please, you can ask questions, you can get hints, you can share ideas for solutions, but please don't share the working code just to let people figure it out on their own. Okay, let's see if we have any questions. All right, so there was a question about assignment 2. No, assignment 1 is due next week, and assignment 2 we will be launching on the 29th of August during the next lecture. All right, so it's great to see the discussions going on here. Now there was a question, can we nest loops for two different things? Eileen asked this question. Yes, you can. You can actually nest loops for two different things. You can nest loops, like you can put a for loop within a for loop and so on. That's perfectly fine. So one quick note, if you're typing any code within a question, I'll just give you a small recommendation. What you should do is, let's say you have a question about some code, like how does this code work? Then what you should do is you should put your code within triple quotes, and these quotes are basically the quote character that is on the left side of your one key, right? So this is right on the just below the escape key or on to the left of the one key. So put in triple quotes and then end with triple quotes. What that does is anything that you type here shows up as code. So let's say if I type for value in person.values, and then I can give spaces here as well. So and then I can put in for key value pair in person.items, and then I can write something here as well, right? So whenever you're posting code, you can simply type it out like this, and that makes it look a little bit nicer. Okay, let's see, there seem to be, okay, there's a question, will you talk about generator expressions? Probably not today, but maybe later on. So if you're facing issues with committing, just or whenever you're facing an issue, please just describe what you have tried exactly, and then we will be able to answer you better. So if you provide more detail, then we'll be able to help you out. Okay, so let's move ahead then. So I'm going to go back to the course page, 0topandas.com, and then I'm going to go back to lesson 2. And now we're going to look at a very interesting topic, something that is at the very core of programming. And that is the idea of functions and scope. Okay, so open up the notebook. Let me just click run on Binder. Wait for that to get started. Again, please do not run it on Binder right now. If thousands of us run it, then it is going to be slow for everyone. But you can try it after the lecture. All right, so let's just go full screen and let us hide the toolbar. So I'm just going to do kernel restart and clear output. Okay. All right. So we've already seen some functions, right? We've seen the print function, we've seen the len function, we've seen the data types related functions which can convert data types from one type to another. And then we've seen methods as well. But just to recap, a function is basically a reusable set of instructions. That is, there is some logic which you think can be used again and again on different data, or needs to be, you do not want to write the same set of code each time you want to do that, perform that operation. So you convert it into a function, and a function takes one or more inputs, performs certain operations on those inputs, and then often returns an output as well. Okay. And Python provides many built-in functions like print, len, and so on. But you can also define your own functions. So this is a print function, pretty straightforward. We've seen this, but here are the inputs. Today is, and then today, that is an input as well, which becomes Saturday. And then the print function simply performs an operation which is displaying the input on the screen. It does not return anything. Okay. So Python allows us to define our own functions as well. So what we can do is we can define a function, let's say called say hello. And now the say hello function can print hello there, and the say hello function will print how are you. So it's a pretty straightforward function. The way to do it is def space function name, and then you have these parentheses or these round brackets. Inside it you can put some inputs, but we're not doing that just yet. And don't forget this colon character. And then the body of the function needs to be indented by 4 spaces, just like the body of a for loop, or just like the body of a while loop or an if statement. Okay. So that's a function. A function has been defined. But when you define a function, the statements inside the body are not actually executed. And that's why you do not see anything printed here. So once a function is defined, you need to invoke it, or you need to call it. So that's the same thing. You will hear invocation, you will hear function call, you will hear function execution. It all means the same thing. So the way to invoke a function is to call the function name. So just type the function name and then pass these brackets. So an open bracket and close bracket, that is used to invoke the function. And you can provide any inputs here as well, but our function does not take any inputs, so we're not going to do that. And then we just run say hello, and that is going to print out hello there and how are you. Let's try it again. So if I run it again, it once again prints hello there and how are you. And that is really the key benefit, that now I only had to write it once, and now I can use it with a single line. I do not need to type out the code again. Okay. But just functions which do not take any inputs are not very interesting. So functions can also accept one or more values as inputs, and sometimes you will see them referred to as arguments or parameters. And there are some technical differences, but ultimately these words are used quite interchangeably. And these, so we'll go with the word arguments because that's the most common thing that you see used. So arguments to a function help us write flexible functions which can perform the same operation but on different values. Okay. So for instance, we'll create a very simple function, and then we'll see this function that is already there. So here we say, we have a function say hello, and we will let it accept a name, and then we will print hello, and we will do a string formatting, and we will pass in the name. Okay. So if we just say hello to John, that says hello John, and say hello to Jane, and that says hello Jane, right? So just taking that idea forward, here is an example of a function. It's called filter even. What it takes is that it takes a list of numbers, a number list as an input, and then it does certain things, and then it returns an output. Okay. So there's an input going on here, and then there's some operations being performed here, and then there is a return statement. So I'll tell you what this operation, what it does, and I'll not go over the code exactly, but what it does is it takes the list of numbers and it only keeps the numbers, it only retains the numbers that are even. All right. So the result list will contain simply the numbers out of list which are divisible by 2. And the way it does it is it loops over the number list and it checks whether that number is divisible by 2 or not. And if the number is divisible, it appends it to result list and then returns the result list. Okay. So let's try it out. So here, and by the way, the return, a function returns, to return a value, you simply say return and then pass the variable or the value that you want to return. And what you can do now is we can invoke filter even with a list of values, and then we can take this output of filter even and put it, so use an assignment operator to assign the output of filter even to the variable even list. All right. So we have we have 1, 2, 3, 4, 5, 6, 7. And then we have the even list. So you can check that now the even list only contains 2, 4, and 6. Okay. And now you can take the same filter even function and then you can run it with a different array. Let's say 1, 3, 5, 7, 9. And this time when we run it, we get back the empty array or the empty list. I'm sorry. Okay. So those are functions. And then now we have functions with return values. So the next thing we want to look at is how to write great functions in Python, because as a programmer, you will be and you should be spending most of your time writing and using functions. The more functions you write, the better you get at programming, because you then learn to structure what you need to do into small functions that you can reuse in different ways. Okay. And we are going to explore how to write a great function and using the many features that Python offers. And we'll do this by solving a problem, right? So let's see. So here is the problem that we'll try and solve. So Radha is planning to buy a house that costs $1.26 million. So $1,260,000. And when you buy a house that's so expensive, you have to probably get a loan. So she's considering two options to finance her purchase. So she has one option, which is to make an immediate down payment of 300,000. So she just pays 300,000 right now and then take a loan, an 8-year loan with an interest rate of 10%. So a loan has a duration. The duration is 8 years. You have to repay it in 8 years. And there is a certain interest that you pay. So there's a 10% per annum interest rate. So I should probably just put in per annum here. Okay, so there is a 10% per annum interest rate. And then there is a 10-year loan, which has an interest rate of 8% per annum. Okay, so she can either take out an 8-year loan for just the remaining amount if she pays 300,000 right now, or she can take out a 10-year loan with an interest rate of 8% for the entire amount. Now, both of these loans have to be paid back in equal monthly installments. All right, also known as EMIs. So now what we want to figure out is which of these two loans is going to have a lower equal monthly installment. Okay, and this is the problem we'll solve, and then we'll build this function step by step. So we'll also see how to build a good function, and we'll use certain features of Python to make it very flexible and powerful. Okay. So the simplest thing that we can do is, since we have to compare EMIs, we need to calculate these EMIs or monthly installments for both of these loans. So it'll be helpful to define a function so that we do not have to type out the same logic for each of these loans. All right. So we're going to define a function called loan EMI. And to start with, we're going to simplify it a lot. We're just going to say that, okay, you just give us the amount and we'll assume that there is no down payment, there is no interest, and the loan has to be paid back in exactly 1 year in monthly installments. Okay. So we simply take the amount and then we divide it by 12 and that gives us the EMI, and then we print out the EMI. Okay. Using the print statement. So our loan EMI function just takes one input. So here we call loan EMI with 1.26 million as the input. So you can write it like this: 1,260,000, or you can also just say 1.26 E6, which makes us 1.26 multiplied by 10 to the power of 6. So that is 1.26 million. Okay. So if you take out the entire amount you want to repay in 12 months, then this is the amount that you need to pay per month. Pretty simple, straightforward, that's fine. So now let's add a second argument. So let's, apart from the amount, let us also include the duration of the loan in months. So after what time are you going to completely repay the loan? So you have the amount and then you have the duration in months. So we put in the duration here, and all we need to do is divide the amount by the duration. And once again, we're just going to return the EMI. Okay. So we've just extended our function a little bit, and step by step, we're going to just make it better. Now, one thing I want to note here before we actually use this function is that you will see that I have actually created a variable called EMI here. Now, where does this variable live? Because if you try to access this variable, let's say I try to access EMI, it says the EMI variable is not defined. And it's not like if I call the function, it will become defined. Like let's say if I just call loan EMI with 1.26 E6 and with a duration of 10 years. So that is 10 times 12. So we need the duration in months. So the function has been executed. But even now the EMI variable is not accessible. Not only the EMI variable, but even the amount and the duration. Okay, so even if you try to access these, they are not accessible. And that is because these are all local variables within the function, right? So a function, when you define a function, within the function, there is a scope. And all these variables which are used inside the function are only available within the function, and they are called local variables. So scope is basically the rules that define where a certain variable is visible. So if you have a variable that was defined outside in a separate code cell, that is a global variable. You can access it anywhere in your code. And then if you have a variable that is defined within a function, that is a local variable. Okay. And that's a very useful thing to have, because now you can define, let's say 5, 10, 15, 20, 100 functions. In each of these functions, you can use the same variable names without worrying about what you do with the variable in one function inside a function affecting the value inside another function, right? So each of these will get initialized from scratch inside the function. So that's just a little note on scope. Okay. So now we can compare a 8-year loan with a 10-year loan. So for the 8-year loan, we pass in 8 into 12, those many months. And for the 10-year loan, we pass in 120 months. We still are not considering the down payment. So you can see that the EMI obviously for the 10-year loan will be smaller than that for the 8-year loan, as you might expect. Okay. And now this is great. We can see visually that these values are different, but it would be nice to compare them as numbers. And maybe we want to calculate the difference and so on. And that is where we can actually use a return value. So let's modify our loan EMI function now. And this time what we are going to do is we're going to return the value of the EMI. So we're going to say EMI is amount divided by duration, and then return the EMI as a value, as an output. So now when we call loan EMI on 8 years, we can actually take the output and then put it into an EMI1 variable. And then we can then go for EMI2 and take the value of the 10-year loan and put it into EMI2. So now we get an EMI1 and EMI2, and we can now take a difference of these two. And we can check, okay, there's a difference of $2,000 between the two EMIs. Again, right now we're not considering down payment or interest. So, but it's a good thing to see how things are evolving. Okay. So next up, let us add the down payment, the immediate down payment, the amount that you're going to pay right now that needs to be deducted, and the rest of the amount is what you need to take the loan for. Now, since the first loan has a down payment, but the second one does not, what we can do is we can make this an optional argument with a default value of 0. So now we still have the amount, we have the duration, but we have the down payment, and the down payment has a value of 0. So now the loan amount becomes amount minus down payment. And now the EMI becomes the loan amount divided by the duration, and then we return the EMI. So here for the, when we have an optional argument, we can invoke it just as a normal argument. So here we say we pass in the loan amount, we pass in the duration, and then we pass in the down payment. That's the first loan, the 8-year loan with a down payment of $300,000. And now we get back $10,000. We get back $10,000 EMI. But on the other hand, here what we have is we've just passed in the loan amount and we just passed in the amount and duration, and we've not passed in a third argument. So when we do not pass it in, Python takes and converts this. Python simply uses a default value, down payment equals 0. So the loan amount simply is the whole amount, and hence you get back the EMI for the second loan. Okay. So optional arguments, very useful to have, makes your functions very flexible and easy to use. Okay. So next, now let's add the interest into the calculation. And this is the part you may have been wondering, how are we going to calculate interest? How are we going to introduce that? And we're just going to use a formula here. And it's not a very difficult formula to derive if you know a little bit of math like arithmetic progressions and such. But I'm not going to go into the derivation of this formula. I have linked to a video if you're really interested in understanding how it works. But the idea here is to get the equal monthly installment, we take the loan amount, which is also called the principal, and then we multiply it with this expression. So we multiply it with the rate, and this rate needs to be the rate of interest per month. So note that the rates that we are given are in per annum. We multiply it with 1 plus r, so that's 1 plus the rate, raised to the number of months, right? The number of periods that we want to talk about. And then we divide the whole thing by 1 plus r to the power n minus 1. Okay. Again, it's just a mathematical formula, and we simply need to convert that into Python code. So let's do that. So now once again, we are going to introduce, we have the amount, we have the duration, we have the rate, and then we have the down payment. Now one thing to notice here is that all the required arguments in the function, the arguments that have to be specified, have to come before the optional arguments. Because what happens is, otherwise, if you invoke loan EMI with 3 arguments, Python may get confused whether you're trying to refer to the down payment or you're trying to refer to the rate, if down payment is before rate, right? So remember to keep all of your optional arguments at the end of the function definition. So once again, we take the loan amount, that is the amount minus the down payment. Then we have the EMI, which is the loan amount multiplied by the rate, multiplied by 1 plus rate raised to the power of duration. And that's why we took the duration in months. And remember, the rate has to be monthly as well. And then we divide the whole thing by 1 plus rate raised to the power duration minus 1. All right. So that's our loan EMI function. And we are getting there. So now we have the down payment, now we have the EMI, now we have the rate of interest, and now we have the duration included as well. So now when we talk about the 8-year loan, we pass in the duration as 8 multiplied by 12. And then we pass in the rate. So the rate was 10% per annum, which is 0.1 and 0.1. So the monthly rate becomes 0.1 divided by 12. So that's what we've put in here. And this was the down payment. And that gives us back what the EMI looks like, around $1,456.7, $14,000 per month. And then similarly for the second option, we simply put in the amount and then the duration and the rate, no down payment, and then we get back the EMI value. Okay. So now this is good. And now we have already answered the question. So we can see that option 1 has the lower EMI. So that's good. Radha can now decide what to do. But if you look at this function call, it's not looking very pretty. It's not easy to tell what are all these numbers that you're putting in here. In fact, it would be really easy to make a mistake here. I could very easily, if I do not remember things correctly, I could just put in this here, and then that would still give me a result, but that would be a completely false result, right? This is completely wrong. So the way to avoid that is to use something called named arguments. Okay. So while invoking a function with many arguments, it can get confusing and there can be human errors. So what you can do is you can specify the name of the argument before the actual value that you pass in. So you can say loan EMI, and then I have written out each argument on a separate line, and you can do that. You can split the function invocation into separate lines, but you don't have to. You can write it all on the same line as well, as I've done for the second case. But the key idea here is you can type the name of the argument, then put in an equal to, and then put the value in. So this can be a value, this can be a variable, this can be an expression. Like here, this is an expression, 8 multiplied by 12. Here is the rate, and then here is the down payment. Okay. So that looks much nicer. Now and by the way, when you do that, you can actually change the order of arguments as well, because you're specifying the name. So you can actually put duration before, the amount, and so on. So that's the EMI one. So that's about one. You get the same result, no change, even though I changed the order of the arguments. Then we have EMI 2. This is for the loan without the down payment, the 10-year loan, 8% rate of interest. And once again, we get back the same result. Okay. So this is fine. This is good. But if you see this, I don't like this whole 10 characters of 10 digits after the decimal, because normally you're going to pay back whole dollars. So what we might want to do is we might want to round this up to full dollars. In just a second. Yeah, so we might want to round this up to full dollars. And what you can do is you can maybe write a function. You can write a function called round up. Okay, and that takes a number X, let's say, and then try to figure out what you can do here. So try to figure out what you can do here, round it up and return the result. And you can use this function inside the loan EMI function. So functions within functions, using functions within functions is a very powerful technique. You can try this out and it'll be a good exercise. But since this is such a common thing, rounding numbers up and down, Python provides a built-in function for it. Except that this built-in function is part of the Python standard library. So because there are a lot of, Python is a general purpose language that is applied to many different use cases in scientific computing, in data analysis, in software development. So it doesn't make sense to just put all these functions into the global namespace, because that is going to just put in tens of thousands of function names into our global namespace. And every time you try to declare a variable, it might collide with a function, or your known function names might collide with functions. So what Python does is it puts them into modules, right? So modules are nothing but files containing Python code. So they can contain variables. So these are files with a .py extension, and then they can contain variables, functions, classes. And what they do is they give you a way of organizing large Python projects into files and folders. And the key benefit that modules offer is namespaces. That is, when you want to use something from a module, and we'll see an example very quickly, you need to first import the module, and then all the methods, all the functions, everything inside a module will have to be accessed using the name of the module, right? So that makes sure that your global namespace that you're working with does not get affected. And that allows people, like if you have 20 people or 100 people working on a project, everybody can write their own modules and they can use the same variable names, they can use the same function names, and that will not cause problems when you want to use those modules together. Okay. So here is and by the way, you can write your own modules, but we are going to use some built-in modules from the Python standard library. Okay. So I'm going to import the math module that contains a lot of math related operations. And inside the math module, there is a function called ceil, C-E-I-L, which stands for ceiling, which basically takes a number and then rounds it up. So if I want to know what the ceiling function does, I can simply call help on ceiling. And here it says the ceiling of x as an integral is what it returns. It takes a single value x, and it is the smallest integer that is greater than equal to x. So that's exactly what we want. So now to invoke this function, we say math.ceil, and that rounds up 1.2 to 2. Okay, so that's great. So now let's update our loan EMI function to, it is the same function as before: amount, duration, rate, down payment, get the loan amount minus down payment, calculate the EMI using the formula, and then call math.ceil on EMI and then store the result back into EMI. So this is just going to do that rounding up. And now if we calculate the EMI, you can see that 14568 is the EMI for the first option and 1515288 for the second option. So we can compare these EMIs or equal monthly installments now, and then we can print a nice message which Radha can view. So you can imagine you're building this system where people can put in a bunch of loan options, and then they get back whichever is the best or whichever has the lowest EMI or whatever they want to optimize for, right? And yeah, and that's it. So that's one way of just using functions, and we've built this function step by step, and we've made it better over time to answer this problem. Okay, but apart from just answering this problem, what we have achieved here is actually we've created a fairly generic function that can be used to solve many other similar problems. And now we do not have to think of that entire logic. Like we do not need to remember the formula. We do not need to figure out how to round things up and so on, right? So let's try a couple more problems and let's see how easily we can solve them using these functions. So here, Sean is currently paying back a home loan for a house he bought a few years ago. So Sean has a loan of $800,000. The loan has a duration. The duration was a 6-year duration. And the loan has a down payment of 25% of the cost, so which is 200,000, right? So there's a down payment of 200,000 on an $800,000 loan, on an $800,000 house. So the rest of the amount is on a 6-year loan with an interest rate of 7% per annum. Okay. Now that's one loan that Sean has. Another option is another thing that Sean is doing is Sean is now buying a car worth $60,000 and he is going to finance this car using a 1-year loan with an interest rate of 12% per annum. Okay. And both loans are to be paid back in EMIs. So what is the total monthly payment that Sean has to make? So, okay, looks a little bit complicated, but if we break it down, there are just 2 loans going on here. So here is the first loan. Cost of house is such and such. The 6 years is the duration. 7% is the rate of interest, and 25% of 800,000 is the down payment. We simply put it into the loan EMI function, and we get back the EMI of the house as $10,230. Here is the second loan. So we have a $60,000 loan. The duration of the loan is 12 months. So 1 times 12. And the rate of the loan is 12% per annum. So we need to divide it by 12 to get the monthly rate. And then we put it into loan EMI. And that's it. We get back the EMI for the car is $5,000 per month. And now we can display the total EMI that Sean makes a total monthly payment of the EMI of the house plus the EMI of the car towards loan repayments. Okay. So yeah, that's great. We've solved another problem using just these 1, 2, 3, 4, 5. This is technically just one line of code split across multiple lines. So 5 lines of code for the first loan and 4 or 5 lines of code for the second loan, and the problem is solved. Okay, let's try one more. This one is a little more interesting. So here what we have is, if you borrow $100,000 and you are on a 10-year loan and you have a rate of interest of 9% per annum. So what is the total amount that you end up paying as the interest, right? So over and above the principal, the $100,000, what is the additional amount that you end up paying? So there's one simple way to do this. And what we can do is we can assume that there are 2 loans, one with interest and one without interest. Okay. So here's the loan with interest. It has the value amount of 100,000. It has a duration of 10 years and it has a rate of interest 9% per annum. So that gives us 1267 is the EMI with interest. Okay. Now let's suppose that there was no interest on this. So what we can do is we can simply get the EMI for the loan without interest. And then if we subtract the 2 EMIs, we get to know how much interest we are paying per month. And then we simply take that over the entire duration. So that gives us the total interest, right? So that's one way of solving it. There are other ways too. So let's put in the amount 100,000. Let's put in the duration and let us put in the rate of interest as 0. Oops, but something seems to have gone wrong here. And let's see what went wrong. Now this will happen to you a lot before you get better. And even after 12 years of doing Python, I still get exceptions all the time. So don't worry if something goes wrong. Just where you want to start is look at the last line. So it seems like this is a 0 division error. So what happens is whenever you try something that causes something to break while the code is executing, Python throws an exception. By throws, what it means is wherever the error occurred, it is going to stop the execution of the program there. And then it is going to just print out this error message for you. So it seems like there was a 0 division error where we were trying to divide by 0. And float division is simply the normal single division. So we were trying to divide by 0. Where were we trying to divide by 0? That is where you now go up and see that, okay, within the loan EMI function, if you check the third line, this is where this arrow points. So in this formula, it seems like we are dividing by 0. And now you can probably guess, because the rate is 0, 1 plus rate becomes 0. And because 1 plus rate becomes 0, 1 plus rate becomes 1. So 1 plus rate to the power of duration becomes 1, and 1 minus 1 becomes 0. So this entire denominator is now 0, and that's a problem because now dividing by 0, is not defined, and so the loan EMI returns an error, and that is why the EMI without interest, the code execution stops at this point and nothing gets printed. Okay, so what do we do? So when an exception is thrown, when an exception is thrown by Python, you have a chance to actually handle that exception. And an exception, the way to handle it is using a try statement. Okay, so here's a small example. So what you do is you say try whenever you're writing some code which you think might cause certain errors. So you say try, and then here I'm going to print a statement saying computing the result, and then I'm going to divide 5 by 0. Bad idea. It's going to break here, and then I'm going to just say computation was completed successfully. So now, since I know that this might break because maybe 0 came in as a function argument or something like in the previous function, right? So when I know that this is going to break, I can put in an except statement and put in the type of error that I might expect. So the except statement, and then the type of error is a 0 division error. So here what it is saying that if you get a 0 division error while executing this code, then do this. So what we do is we print that we failed to compute the result because you were trying to divide by 0, and then we set the result to none, and then we simply print the result out. Okay, so you can see here it says now computing the result. It tries to compute the result and it blows up. Now the print statement, this one does not get executed because we've broken out of the execution, but the except handles the error, and then these two statements get executed. So we say that you failed to compute the result, and result has the value none. This on the other hand, if I were doing 5 divided by 2, so now this runs normally. So we never come into this error case, and we simply print out that the computation was completed successfully and the result has the value 2.5. Okay. And this is what you can do. You can actually have multiple except statements if you know that there can be multiple types of errors or exceptions that can be thrown. And Python has a lot of different exceptions. So you can actually check out, I've pointed to a link here. You can learn about more exceptions in Python. But what we want to do is we want to just take the loan EMI and add the try except inside it. Okay. So what we want to do is we want to try to calculate the EMI for the loan using the formula that we had. But if that returns an error, especially if it leads to a 0 division error, then we can say that if the 0 division error will occur only when the rate is 0. And when the rate is 0, you can simply divide the loan amount by the duration, right? So then we simply divide the loan amount by the duration, and that handles the error for us. Then we again round it up and then we return it. Okay, so that's great. So now we can use this updated loan EMI function. Once again, the question was you borrowed $100,000 using a 10-year loan with a rate of interest of 9%. What is the total amount you end up paying? So we calculate the EMI with interest, and then we calculate the EMI without interest, and this time it works even with the rate of 0. And then we can see that, okay, there's a significant difference with and without the EMI. So we do the EMI with interest minus the EMI without interest, and then we multiply it with the duration of the loan, which is about 10 years, right? So 10 times 12, those many months. So that gives us the total interest that is paid. And now we can display that the total interest paid is 51,960. Okay. And that's a good thing to know whenever you're taking a loan. What is the total interest you're going to end up paying? And are you okay with that versus just paying it right now? All right. So one last thing now, we can also add some documentation within our function using what is called a doc string, right? So this is what we saw the help method that we used with the seal math.seal. Okay. Now, if you want to add explanations within your own functions, and you should do that, the way to do that is to include a string as the first statement within a function. So here I'm using a multi-line string. So here I'm going to say that it calculates the equal monthly installment for a loan. So that is a description of the function. And by the way, you can just write that, and that should be good enough too for a lot of things. So you do not need this necessarily. But anyway, I'm going to use this too. So I put in one line about the function, then I am just giving a space just to make it a little clearer. And then I'm going to just describe the arguments as well, that the amount is the total amount to be spent. So here I might want to specify that do not this should be the loan amount plus down payment that you're putting in. Then the duration is simply the duration of the loan, but in months. So that's an important detail to give. And then the rate is the rate of interest, but it's monthly. And then finally, the down payment is an optional argument. It is an optional initial payment deducted from the overall amount. Okay. So this is how you, this is how you document a string, document a function. That is, explain what it does for the people who are going to use this function. And the rest of the body of the function is the same, right? So the rest of the things just go in the body. Now, when you have the documentation, you can simply call the help function, and you can see that the same documentation gets printed. So this is very useful. It will be useful for you. It will be useful for others using your function. It will be useful for people reading your notebook as well. So whenever possible, write documentation for your functions. Okay. And now we can just save and upload our notebook. So again, since this is running on Binder, I don't want to lose my work. So I'll just grab my API key here and put it in. And as you keep committing notebooks to your profile, they will get added up here. So you can see here, I have a bunch of these notebooks. And you can always come back and run any of these. And then if you commit again, then they will get updated. So each of these notebooks, you can see how many versions they have and so on. And you can also share these notebook links online with your friends if you want to just say give a quick tutorial or answer a question. Specifically, even on the forum, if you want to answer a question and you can quickly create a notebook to do it. So you just do new notebook, create a new notebook, run it on Binder, type out the solution, and then commit it back. So once you get a notebook on Jovian, you can commit it back and then you can simply share the result on the forum. Another thing to do is if you're getting stuck at some point, then just commit your notebook and take the notebook link and post that on the forum saying that this is what I've tried and this is how I failed. Unless you describe what you have tried, it's very hard for people to help you out, right? So generic questions like I'm not able to solve this problem is not very helpful because people will not be able to help you. So the best way to get help is to offer as much description about what you've tried. And the best way to do that is to share the actual notebook that you have been using, right? Maybe just the piece of code that you are working with. Okay. So that's about functions, and there's a lot more to functions. So just a quick review of what we've covered, and I'll talk about an exercise for you. So we've talked about creating and using functions, and we've talked about creating functions with one or more arguments. And we've talked about local variables in scope and returning values using return, using default arguments, using named arguments while invoking a function, importing modules and using the library functions, reusing and improving functions to handle new use cases. So what we saw was we kept improving the loan EMI function over time. And this is something that you should do a lot, keep improving your functions. And we handled exceptions using try except. And then finally, we documented functions using docstring. So that's a lot of ground that we've covered in just 45 minutes. So I hope you've been able to follow. And if not, you have this notebook. So experiment with the notebook. So what you should be doing now, after the lecture, you should be going file, new notebook, Python 3. Take this notebook, put it on one half of the screen. Take this other notebook, the existing notebook, and put it on the other half of the screen. Okay. And now what you should be doing is you should be actually typing out all of these things by yourself. So for instance, the loan EMI function, instead of just looking at the function and trying to understand it, you should be defining, you should be saying def loan EMI. And I'm just going to take the amount right now and return amount divided by 12. And then just try it out, just try to break things. Just say, okay, what happens if I pass in loan EMI? I take a loan of $100. Okay, that seems to be the EMI. Now here you might get certain ideas. What if I pass in two arguments? What if I call it without any arguments? If you call it without any arguments, it says, oops. It's going to tell you that the loan EMI has one positional argument amount which you have not passed. You can try calling it with multiple arguments. That's going to give an error, right? So all of these questions that you might have, the more curious you are, the more you break things, the more you learn. And the best way to do that is to just type out the code yourself, because as you're typing, you will wonder, what can I change here? What can I break here? And the more you explore, the more you learn about Python, the better a programmer you will become. Okay. All right, so now we have an exercise for you. This is not an assignment or anything. This is just for you to understand. So here you're planning a leisure trip and you need to decide which city do you want to visit. So you've shortlisted 4 cities and you've identified what is the return flight cost and what is the hotel cost per day and what is the weekly car rental. So cars have to be rented for full weeks. So even if you want to use a car for 2 days, you still have to pay for the week. And hotels are rented per day or per night. And then you have the return flight, which is just a one-time cost. Okay. So using this data, and this is a real life example of, again, some analysis that you might have to do in real life. So using this data, if you're planning a 1 week long trip, which city should you visit to spend the least amount of money? Okay. So that's one question you can answer. And how does that answer change if you change the duration of the trip from 1 week to 4 days or maybe 10 days or 2 weeks, right? So it's a good thing to explore all these things. If your total budget is $1,000, then which city should you visit to maximize the duration of your trip? Or maybe you actually do not have a lot of time, but you'd have a good budget. So which city should you visit if you want to minimize the duration of your trip? Right. So these things are something that you can figure out. And then you can change the budget, try $600, try $2,000, try $1,500 and all of these things. And to do this, it will be very useful for you to define a function like cost of trip, which will take in all the relevant inputs like the flight cost, hotel rate, car rental rate, and duration. And it will calculate the duration of the trip. All right. And calculate the cost of the trip. And then you can use that to answer all of these questions or any other questions that you may have. So do try this out. This is going to be a good exercise on functions. And what we will do next time is we will continue working on functions, but we will also see how to work with files. So we will process some files and then we will perform certain data analysis and certain operations from data read from these files. Okay. So that's where we are. Now, what should you do next? Try out the notebooks yourself. As I said, open up side by side and then type out the code. Start working on the assignment. So assignment 1, once again, just to repeat, you go on the lecture page 02pandas.com, click open here on assignment 1 and run the notebook, make some changes, commit it back to Jovian, take the Jovian link and submit it here. And you will see the grade as pending for now because we have a lot of assignments to evaluate and we will only evaluate your last submission. So we'll take your last submission and evaluate it, and based on that we'll give you a pass or fail grade, and that will be done. You can expect results in about a week. The course enrollments are still open. So if your friends want to join the course, please invite them to enroll till the 29th of August, and they just have to do the first assignment in time. They can watch the lecture videos. The lecture videos, lesson 1, lesson 2 are both available here to watch. So please do that. Another very important thing to do to really learn things well is to ask and answer questions on the forum. So I would suggest make it a point to answer questions on the lecture forum thread, which you can access from here. So here's a discussion forum thread, or in general from the course page, you can just find the course community discussion forum. So you can click through to that link as well. And you can find all the discussions that are happening, lecture 2, assignment 1, lecture 1, and so on. And just try and at least ask 1 question per week and answer maybe 2 or 3 questions per week. The more you answer, the better your understanding becomes as well. So please do that. A lot of people are helping each other. So I just want to give a shout out to everybody who has been helping out on the forum. Thanks a lot. We cannot run a course of this scale without such great community discussions happening. So please do participate. Another thing that you can probably do is you can join a study group and learn together. So if you're not comfortable interacting publicly with such a large audience, then you can actually you can join a smaller group. So we have a bunch of study groups for time zones and cities around the world. Like we have a bunch in India, we have Brazil, we have Europe, we have Korea, we have Malaysia, we have Mexico City, North America. So all of these groups are there. And what you can do is there's a link to join the group. So you just click on the link and then click the join button. Sometimes you will see a request button. So you may have to request access and the group moderator will let you in. And then you can simply open up the group. And on the group, you can then look at the different topics. So on the North America study group, there seemed to be a discussion already going on the first assignment. And you can have a discussion with a smaller group of people, maybe 10-15 people. You can get to know them, you can get to have weekly calls with them, and study groups are a great way to stay motivated. Another suggestion is create a study group with friends. Get 10 friends to join you in signing up for this course, and then you can all do the assignments, discuss the ideas, discuss the lectures, do the exercises in the lectures together, help each other out, and stay motivated for the 6-week duration of the course, right? Online courses have a large drop-off rate because it's hard to stay motivated, but with a group you can actually get it through to the end. And we've seen that people who were part of a study group or were active on the forums were 5 times more likely to complete the course than people who were not. So if you need help there, if you think you need help completing the course, just participate in the forums. Okay. Now we're also doing office hours. So we're doing office hours on Wednesdays from 9 to 10 p.m. Indian Standard Time, where we'll do a walkthrough of the weekly assignment. So we'll dig into the assignment, we will share some hints, and we will also try to answer some of the most common questions or most popular questions that have been posted on the forum. So we'll send you, again, you can find details about the office hours on the lecture discussion threads, on the discussion forum. So here you have office hours, bringing you closer to the course team. We've already done office hours last week, so you can access those videos here. And then we will be doing office hours this week as well. And in general, by the way, if you are on the forum, so jovian.ml/forum is the forum link. If you want to find the course discussions, you will most likely see them in latest, but you can also go to course discussions and then open up data analysis with Python 0 to pandas, right? And this is where it will bring you back to the forum. Another interesting announcement that I have for you is that we are launching a data science mentorship program. So a lot of people have reached out to us over the past year and a half, saying that they have access to a lot of courses, they have access to a lot of learning material, they have access to, it's probably too much, a lot of data sets and a lot of resources, but they're not quite sure where to start, how to organize their learning, how to get and then how to build a professional profile and get an internship or a job. And that is why, to help you out, like if you're serious about pursuing data science as a career, and if you're looking to make a switch into this domain within the next 6 to 12 months, so we are launching a new mentorship program. So you can find the details on jovian.ml/mentorship, and we will share this link in an email as well. So the data science mentorship program allows you to advance your career with personalized guidance from industry experts. So what we're doing here is, this is a very limited and exclusive, and it's a paid program. So we are only going to take in a very small number of people, because we're just launching the program right now, and we're going to have a small number of mentors who will guide the program participants. And the benefits of this program is that you will be given access to a private Slack group. So you will have instant messaging contact with all the mentors and the jovian.ml team and other participants of the program who are also looking to build a career in data science and are really serious about it. So, and then you will be able to schedule weekly one-on-one calls. So 1 hour per week, you will be able to schedule a call with your mentor apart from all the discussions you're happening on Slack. So this is just like a video call for personal guidance on any of these areas, right? So the first thing that we'll do is we'll craft a personalized learning path for you. So we will identify which courses you should do and in what order, and what are the certifications you should pursue and what are the projects you should do. We will also help you. Will also help you identify projects, and we will guide you with those projects. So when I say we, I mean the mentor. So they will be able to help you plan one project every month, something that you can do on a real world data set, something that matches your skill level, and we'll do an in-depth project review with you and give you actionable feedback on that. We'll help you create a professional profile by rewriting your resume from scratch, by helping you put your best foot forward with a strong LinkedIn profile. And based on your progress, you will also get a personalized recommendation on LinkedIn from your mentor to endorse your progress. To help you with interviews, we'll have mock interviews and actionable feedback there, where we'll help you identify your strong and weak areas. And as I said, a lot of this is also going to happen on Slack, a private Slack group, which is exclusive only for the participants of this mentorship program. And I just want to mention, this is just completely separate from the course. The course is completely free. You don't have to pay for the enrollment. You don't have to pay for the certification. You can get a certification for free. You can do a project on your own. This is something additional for people who are like really serious and are looking for help, one-to-one help on in getting into data science. And it's a very limited program. And we have an application process. So there is an apply now button. You can just click through here. This will lead you to a Google form and you can just provide your details. It will be helpful if you've completed some basic programming or data science courses. Like if you're doing this course and you have a good hold on programming already, then that might be good. And it should be, ideally you should be looking for a long-term commitment, although you only have to pay month for month. So that's not an issue, but you should be willing to commit 10 to 12 hours per week towards learning and then towards building projects. And you should be seriously planning to look for a job or an internship in data science within the next 6 to 12 months, right? So if you're making a career switch, then this program might help you. It might really help you get a job faster, get a better job, get a better pay and things like that. And then the program fees. So since this is the first batch we are starting right now, this is the program fees is just, we've cut it down to $49 per month. The originally planned was $150. And again, we are accepting very limited participants. So if you're interested, please apply now. We will evaluate applications and then we will roll out invites on a first come first serve basis for the first batch of the mentorship program. All right. And then here's a webinar here linked here at the end. So you can watch this webinar. This tells you how to decide if you should pursue a career in data science, what topics you should learn. So a lot of the advice that we'll give is available here in the webinar, but if you want personalized advice and like personalized guidance, that is what the mentorship program is for. Okay. And once again, completely separate from the course. So course is free, registration is free, certification is free. And that brings us to the end of today's lecture. We've covered a lot of material today. I was pretty excited to share this with you. I hope you were able to follow. If not, please rewatch the lecture, work through the assignment, work through the lecture notebooks, do the assignment, talk to people on the forum, ask questions, try your own ideas, try to break the code. The more time you spend on this, the better you will get at it. So I will see you on the forums and we will join you live next time. Thanks a lot and have a great weekend.